In lesson 1.2, we're going to be looking at linear equations in two variables. That means there's an x and a y. In example 1, we're sketching the graph of the linear function in slope-intercept form. So let's real quickly refresh what slope-intercept form is. That would be y equals mx plus b, where m is the slope and b is the y-intercept, where it's crossing the y-axis. So if we're looking here, my slope is 2 in part A, and my y-intercept would be 1. So now to graph that, draw your x and y axis, and then you're going to have a start with your y-intercept at 1. You can turn your slope into a fraction, so that's saying up to right 1 from your starting point. So you're going to go up to right 1 from there and connect those points with a straight line. And that is your graph. So here we see there's no x. So you can rewrite it like that if you want to look at part B like that. So then what would be the slope and what would be the y-intercept? Hopefully you're thinking that the slope is 0 and the y-intercept is 2. So let's graph that. So I'm going to go up 2, which is my starting point on the y-axis, and then my slope is 0. So that means that's like having 0 over 1. You're going up 0, right 1. So if I go up 0, right 1, that would be right there. And so what you're looking at is a horizontal line, and this is called a constant function because the y value stays constant. It is always 2. Over here, part C, you need to get it in slope-intercept form first. So how would you get y by itself? Hopefully you're thinking you would subtract x to the other side. So now it's like that, and then ask yourself, what's the slope and the y-intercept? And hopefully you're saying slope is -1 and the y-intercept is 2. So go ahead and graph that. You're going to go up 2, make a point, and then your slope is -1 over 1. So you're going, down 1 since it's negative, and right 1 since it's positive. So down 1, right 1, and then connect those with a straight line. And there is the graph of that function. Example 2, the maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that rises 22 inches. So that's vertical over a horizontal of 24 feet. Is the ramp steeper than recommended? Well, let's change. So we're looking at 1/12, but we need to go ahead and change either inches into feet or feet into inches. Let's go ahead and do feet into inches. So we're going to have 24 feet. Let's do some dimensional analysis. 1 foot is 12 inches. And so you're going to multiply 24 and 12. You're going to get 288. Okay, so now let's compare. So if the recommended is 1/12, that's recommended. And what we have is, and remember slope, so I haven't said this before, but slope is rise over run. So that's your vertical difference over your horizontal difference. So the vertical, the rise is 22 inches. And in this case, the horizontal was 288. So that's the run. Now let's simplify that. Let's see, what can we take out of 22? We can for sure take out 2. And that is it. So that would be, if I take out 2, I'm going to get 11 over 144. And we just want to now compare those. You can either change them into decimals, or if you want to get a common denominator. So 1/12 is equivalent to, if you multiply the top and bottom by 12, you get 12 over 144. And so you can see that the ramp and the recommended slope, the ramp is less than the recommended slope. That means the slope is shorter and safer. Is the ramp steeper than recommended? No. It is safer or less steep. Example 3, a kitchen appliance manufacturer company determines that the total cost in dollars of producing X units of a blender is C equals 25X plus 3,500. Describe the significance of the y-intercept and the slope of this line. So when you look at y-intercept, this is always a starting amount. And then your slope is your increase or decrease. Decrease. Okay, so from there, what we're looking at is total cost in dollars is C. Okay, X is the number of units of a blender. And 3,500 is what we're starting with. So the 3,500. Remember, we got to remember what the output is. The output is dollars. So we're talking about money here. So that means we're starting with so the y-intercept means we have a starting cost of $3,500. That's how much this costs to manufacture these blenders. That could be the cost of the workers, the machinery, and the facility. Then you look at the 25. This is positive, so that means the cost is increasing. So every time we make one unit, every time we make one blender, it's going to cost us $25. So every time we increase the number of blenders, that's another $25 increase. So if I put 2 in there, it'd be 50. If I put 3 in there, it'd be 75. So the slope is telling us that for every new unit or blender, there is an increase of $25. And that is affecting the overall cost. Example 4, we're going to be writing the equation of a line in slope-intercept form. I prefer that we use point-slope form to do this. This is common in calculus, and also you may have seen other different ways of doing this. So if you have a different way, that's fine, but I'm going to use what I need my calculus students to use. So that point slope form is y minus y1 equals slope times parentheses x minus x1, where you've got a slope that you plug in for m. In this case, that would be 3. And then you have a point, which is why it's called point slope. You have an x and a y, which is why they give you the 1 and the -2 to plug in. So now I'm going to plug those in. It'll be y minus -2 is the y value given. The m is 3, and that's given. And then x minus the x1 given is the 1. Then we're going to simplify. That would be positive 2 because of the double negative. We're going to distribute the 3. We're then going to subtract 2 to the other side to solve for y, isolate the y variable. And that gives me y equals 3x plus 1, which is my equation in slope-intercept form. In example 5, we're going to do the same thing, only they give us 2 points instead of giving us the slope. So the first thing we need to do is find the slope. That would be this equation. Slope is y2 minus y1 over x2 minus x1. So make sure that is written down somewhere. So that's your slope equation. Now we're going to start there. I'm going to start this problem for this part of the notes, and then we'll finish it in the next part of the notes. So if I plug in, you can decide which is, these are all x's and y's, but you can decide which is 0.1 and which is 0.2. It doesn't matter. And then you plug in those accordingly. So the slope would be y2 is 1 minus y1 is 0. x2 is 3 minus x1 is negative 2. Here I'm getting 1 over 5. So my slope is 1/5, and that is how I'll start the problem, and then we'll come back in part 2 to finish it.